In this chapter, we're going to talk about sequential circuits, so circuits that have memory. So we'll start by talking about state elements, and then we'll talk about generally what it means to be defined as synchronous sequential logic. And then we'll talk about two types of synchronous sequential logic, finite state machines and parallel circuits or parallelism. And then we'll also talk about how we calculate the timing of these sequential circuits. Sequential circuits have outputs that depend on not only the current inputs, but also the prior inputs, so the values of the prior inputs. And so in this way, a sequential circuit has memory because it remembers not only it doesn't just use the current inputs, but it remembers what the prior inputs were. So for example, on your smartphone, if you're entering a code into your smartphone, it has to use memory because it's not just remembering the current value of a code you're putting in, but the prior digit that you entered as well. And so we need sequential circuits because they can remember what the prior inputs were. And so let's define a few terms here. First term is state, and state is all the information about a circuit necessary to explain its future behavior. So for example, if you're entering the code 315 or something into your smartphone to unlock it or something, then this the state would be holding, well, what state are we in? Have you entered the 3 yet? If you have, then you've entered the 3 state. And so now your smartphone is in that state waiting for the next correct input of 1. And then once the 1 is entered, it's now in the state of, okay, I know that you entered a 3 followed by a 1, and now it's in the waiting for the 5 state. And so the state of a system is all the information about a circuit necessary to explain its future behavior, so what it does next. We're going to use latches and flip-flops to store this state, and we encode the state using binary values. So we encode the state using bits. And actually, we're really going to use flip-flops in this class to store the state. But either latches or flip-flops can be used. And we'll define what those are next. So synchronous sequential circuit is a sequential circuit that uses flip-flops, and each of those flip-flops share a common clock. And so the clock is like on your PC or your computer when you buy it and you get a computer that has a 2 gigahertz clock. That's the clock that we're talking about. So it's this common clock that all of the circuits, that's why it's called synchronous, because they're all responding to that clock. And we'll talk about how that clock is used in the circuit in this chapter. So sequential circuits give sequence to events. So that's why they're called sequential circuits. There's some sequence, like the code we talked about, 315. We need to know a sequence of those events. First detect the 3 input, and then the 1 input, and then the 5 input. So that's the sequence that we're looking for. These circuits have memory, not infinite memory, but short-term memory, remembering the prior inputs. And the way that they have memory is by using feedback from the output to the input to store information. And the information that's stored is bits. So again, state is everything about the prior inputs the circuit needs to predict its future behavior. And it's usually just 1 bit, and it's the last value that was captured, or the last state that was captured. So we're going to use these circuits or these elements to store the state. And we're going to talk about 4 types of state elements: the bistable circuit, SR latch, D latch, and D flip-flop. And the one we're going to end up using is the D flip-flop.